Hello everyone. My name is Mark Dingman. Last week, the Munro Live team put out a video where they were walking around the Tesla body structure and the castings as well with Lars Moravi, the VP of Vehicle Engineering at Tesla. There was a lot of good content in that video. From my background as an automotive structural engineer who's spent a lot of time on EV structures, as well as the implementation of large castings into the automotive structure, there were a lot of other things that jumped out at me. So I wanted to package that information here and share that. Thus, I'm calling that supplemental observations. Be forewarned that a lot of these observations are going to be rather detailed and specific. So whether they're only interesting and helpful to someone in the automotive industry who's working on these kind of things, or not, I don't know, but you can give it a try. So DAFNIS, real quick on DAFNIS, it's just my gateway for automotive structural consulting. If you want to know more about that or who I am and my background, just go to dafnis.co. I don't want to spend a lot of time on it here. So how are we going to do this? Because it's going to be tricky. The Munro Live information is, I don't know what YouTube calls it. It's not a creative something. I'm not going to use the images from the Munro Live video. I'm going to need, if you're interested in this, I'm going to need you to run these videos side by side. We're going to stop at specific time steps of the video to talk about the image that we see. If you haven't watched the video yourself already, it's probably worthwhile to blast through that and watch it before you see what I have to say about it. But to find theirs, go to Munro Live, find that in YouTube, search on YouTube for Munro Live, you'll find it, then poke on videos, and you're going to be looking for the one that I've got arrowed here. It's a picture of the CyberTruck body structure. Tesla head of vehicle engineering discussed, blah, 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 blah. So load that one up in a different browser, and again, we're just going to stop at different times and discuss the images that we see. Before we even get to any of the pictures in here, from a macro view of what we saw in the CyberTruck body structure construction, very similar to the Tesla Model Y, the GigaCast generation. We have a front casting assembly and a rear casting assembly coming together, and call it body and weight complete. The side door rings, the body side assemblies come on from the side, bolt to the castings, and I'd expect to see adhesive in this product as well to create a body structure complete. Kind of a body structure system. In GA, the propulsion battery comes from the bottom and closes that out. As I say that, I do have my notes over here that I'm going to check on each slide. So noticeable differences. Yeah, of course. The exterior panels on the CyberTruck are applied in GA. They're not welded to the body structure like the Model Y, at least the rear quarter panel and A-pillar and things like that. So they don't go through a paint shop operation with the body structure. Of course, this is not an SUV, fold seat back, blah, blah, blah. So this has a back body panel. Here it's a pickup structure. It has something to block the pickup bed to the occupant compartment. You don't have to skip here, but at 212, the image in 212, it really looks like the dash panel here in this execution is metallic, where in the Model Y GigaCast, this was a non-metallic dash panel. At 212, we see what looks to be like resistant spot welds and projection studs on this dash panel, so it's got to be metallic. Advancements from Model Y. If you look at this joint here, and we'll see it later, and if you're familiar with Model Y, I'll call it the framing joint, where we drive bolts from the door ring to the casting. All of those bolts appear, right? What we see in the video is we see two sets of bolts that are laterally driven. There's a forward set and a rear set. but they're all lateral, whereas the Model Y had a combination of lateral and fore-aft. That, in addition with what we appear to see in the videos here of the body in white, is that the sealing surface on the casting that mates to the door ring is planar. It doesn't seem to have the joggles that Model Y GigaCast had. So all that comes together of like that this could be a better dimensional fit condition for Tesla, depending on what we haven't seen here. But that's a difference and a potential advancement. Okay, another macro view, exoskeleton, and I'm sorry to say this, but that exoskeleton is not an exoskeleton. This is not a monocoque structure. The exterior panels here for the rear quarter and fender and A-pillar roof rail applique, they're hang-on panels. They are not attached to the body structure in a sufficient number of attachments, and I would say structural attachments to make these things act as an exoskeleton with regards to stiffness. Now, when I hear skeleton, I think stiffness, not necessarily bulletproof. This could be more like this is a body in white with maybe with a flak jacket or something on it, right? Not a monocoque structure. And yeah, as we recognize that and understand what this is with respect to the panel, I can't help but to think of the first generation Saturns. And the first generation Saturns were very similar in terms of you had a body in white that was constructed in body shop assembly, went through a paint shop and got alpoed, but it came into general assembly with no show surfaces whatsoever. All the panels on a first generation Saturn were hang-on and bolt-on in GA, nearly identical to what we see here in the CyberTruck. So why would CyberTruck want to do this? I'm going to get to maybe their biggest thing in the next slide, but Tesla is always trying to figure out how to produce a value to the customer, but at a less expensive cost. They're trying to stay in business. So yeah, okay, material costs for stainless steel is higher than any kind of metallic material, but say they did this in steel instead of aluminum. Eliminating the primer and paint, clear coat operation, and all the stuff in paint shop that comes along with having your hang-on panels, your exterior panels part of the body in white. This would be an interesting business case. This could be a cost save for them. Again, push the material of the exterior panels aside. You could imagine doing this in a different hang-on panel material, and perhaps this is saving them money. Okay, the low-pass topology strategy. So far, this looks very similar to the GigaCast Model Y. There are a couple parts that I want to see before I make that total conclusion. And what is the structural load path topology of the GigaCast Model Y? Not going to get into it here. It's fun and complicated and a long story. And here's where those exoskeleton comes back into play. We look at forward thinking, right? Because a lot of Tesla products show, a lot of Tesla structural solutions have a progression through their product over the years. Considering these panels are bolt-on, this looks to be the next step towards an unboxed manufacturing strategy. This, I believe, could be used as a testbed for Tesla to prove out in the physical world of what unboxed means. So really, really interesting. All right, so now here's where we start with these time frame things. So what I'm going to do is I'll pause a little bit, but go to 44 seconds of the Munro live video, pause it, and then we'll talk about that. We'll do that for each one of the slides after this. So what did we see at 44? The thing that jumped out at me, and I guess, Lars is gesturing to the B-pillar to talk about the inner outer, or I think Taylor welded blank hot form steel. It's pretty common in the industry, not 100% for sure. But the thing that jumped out to me is, and I'm looking at my screenshots over here too, the weld spacing in the seal flange on the B-pillar are pretty big. This is an area of the B-pillar that's very important for buckling resistance for roof strength. And I'm really surprised to see the spot weld spacing that large. Even if there's structural adhesive in this flange, that's really interesting. You do notice that they staggered the spot welds front to back. That can help buckling resistance, but again, just an observation, right? And then the next one is 51. So 51 is a shocker and a jaw dropper for me. Lars says something to the effect that the body in white is covered or coated with powder. My mind jumps to powder coating as opposed to an Alpo E-coat treatment. So they made a lot of changes to the body shop, or they enabled themselves to make a lot of changes to the body shop by not having their exterior panels have to process through that operation. But if you're going to powder coat the body, there's a real challenge to get I'll say, corrosion protection coating on the inside of the section, the rocker, for sure. And I'm really wondering if that was, if Lars meant e-coating, or if this is truly powder coated. As corrosion very often starts on the inside of a steel section. So if you're not going to be able to cover that with powder coating, interesting one. I'll leave it there, and I'd love to hear a clarification. Next one is 53. 53, what we can see here, and there's just glimpses of this, but it appears that the CyberTruck is following the Tesla Model Y dimensional strategy for doors to body side. This would explain the door gap performance that people have been seeing on the CyberTruck. Assuming that the quarter is where it is and where the fender is where it's supposed to be. What they did on the Model Y in terms of having let's call it a net door to body side fit, would continue that good door gap performance. I think later I talk about the challenge of something we see with Tesla dimensional. Yeah, I'll leave it there. Next one's 53, same slide. In the back, we can see that, I should say on the back, on the far side, A-pillar casting to front body hinge pillar, right here. We can see this, the second set of, I'm calling them framing fasteners between the casting and the door ring assembly. You'll see little geometric stiffening features between them, but they're fairly easily seen. They're driven inside a card out. That's the rearward set. All right, and this is at 135 is the next one. At 135, the lighting isn't great to see kind of underneath the A-pillar, but it does give a glimpse that perhaps the A-pillar roof rail applique has maybe some fold-over tabs that interface to the underside of the A-pillar section, and that's how these things are attached. It looks like a tab for a, call it vertically down to up fastener, into the underside face of the A-pillar on the body structure. Next one is let me make sure, yeah, 212. And 212 is the inside of the front compartment. And we see a couple things here. We see a front compartment upper rail extension that comes forward up off the top of the casting and turns down and interfaces the side of the front rail at the very front. It looks to be a mounting surface for the fender, likely the outboard position of the front end module, and perhaps some frunk trim, but we can see applied part there as to the casting. We also see a folded bracket and a small casting mounted to the inside of the rail. Kind of the bottom part of the image, just the casting is right behind the O in Munro. These look to be, at least the rear one, looks to be the part of the engine mount. The interesting thing there is the fastener is driven outside a car to in, something that would be difficult to do in a manufacturing operation with, I'll say, manual labor, human labor. But given Tesla's tendency towards automated assembly, maybe that's how they get away from that. But a blind operation for sure, and an interesting fastening direction. Yeah, and the image also shows a traditionally difficult sealing area in the body structure. And this is, if you kind of put yourself on the inside of the wheelhouse and you walk rearward, and the wheelhouse starts to turn outboard as it approaches the dash, that surface between the wheelhouse and the dash is often very hard to get sealing equipment in to apply that. It's difficult to say in the image of whether or not we can't see that because it's around the corner. We can't see the sealer because it's around the corner of the wheelhouse, or Tesla just didn't do it. We can see sealer at the top, and then it either goes out of view or they stopped. So that'd be an interesting thing. I'd be interested when I see the car to see what that condition is. The next one is 212 as well, and if you look through the big rectangle or big square access hole on the dash, you can see the inside of the rocker inner, and there appears to be a plate that's mounted to the rocker inner. This is I would say this is a strategy that Tesla has used on some of their products, and it almost certainly is there to make sure that the energy absorption system in the rocker has good footing on the 2 and the 3 bar, and the 2 and the 3 bar don't actually just punch through the rocker system there in a side pull event. So that's interesting there. I can't recall. I got to go back and look at my pictures to see if I saw that on the Y and the 3, but certainly it's there in the S and X. 214 is the next one. 214 is the front casting from the outside looking in the wheelhouse. And I think this view gives a great example of Tesla's use of really a shear panel load path strategy in the front compartment back to the front body hinge pillar. You see how the inside surface of the wheelhouse, vertical surface of the wheelhouse, turns back to the front body hinge pillar. There's not a lot of interruptions to this load path. It's fairly direct, and it's tall. It goes from the bottom of the rocker all the way up to the base of the A-pillar. When I first looked at this casting and saw one, I was blown away at the content or lack of content in the torque box there. Front rail as it transitions down to the front of the rocker. It's an open section. It's not closed. There's not a lot of I'll say, rib features that help guide that load down to, we'll say, a traditional load path. I know there are things in the Tesla crash strategy that lessen the need for strength for torque boxes, but this was really surprising even from a stiffness perspective. I know there are other load path topology strategies that Tesla's using in the front rail. Won't get into coming into the front of the battery, right into the one bar lower. But this was again, sorry, this was surprising. I wonder how it does in durability. I really think that one of the things that helped Tesla here is the use of this shear load path strategy from the front compartment to the front body hinge roller. All right, next one, again, is 214. Lars was talking about the ribs in the casting on the outside and how they are compromised from a structural efficiency perspective. From a structural efficiency perspective, we want to have direct lines from load input to boundary conditions and a lot of triangles and straight lines. And he mentioned that there was a balance created between structural performance or structural efficiency, I'll say, and mold flow. Mold flow was really important because they downsized the casting press that they needed to do this, and that's important as well. I would be interested to ask the question, did they meet structural performance with the rib pattern that they came up for die flow? Or did they had to add a little bit of aluminum material to meet their structural performance as the ribs got less efficient for structure? Or was this fine? Another thing that Tesla is, I believe that Tesla is decent at throwing into the balance mix is performance. This doesn't need to have the ride and handling and chassis interface stiffness of let's say, of a BMW. So maybe these are good. I would be interested in durability, though. Really interested to know what their durability cycle is and how this front end in aluminum holds up, as this is a truck, right? Next one, 225. This is the inside of the front compartment, but at a casting level. And a couple interesting things here. The first one for sure is the profile of the front compartment mid-rail. Typically what we would see in an automotive execution is let's say, we'll call this a hat section, a square section. Sometimes it's closed out in a metallic execution. In the Giga casting, this is open section hat. The interesting thing here is the profile of the Tesla truck has this, let's call it a double wall on the inside of the hat. I can probably rationalize how this might have helped their crush efficiency of the rail for crash. I don't know, without thinking more about it and seeing more science behind it, it just say that this is atypical, certainly something that was born out of something that Tesla did. The other thing that's interesting is that the wave features on the inside surface of the front compartment mid-rail, those are obviously there for engineered crush in rail collapse and front crash events. But the interesting thing is that the wave geometry extends pretty far rearward. It extends rearward of the front of the wheelhouse, but even rearward of maybe even shock center. From the video that Tesla showed at the CyberTruck delivery event, it did not look like very much of that rail was crushing at all. It looked like a pretty stiff pulse. And perhaps these undulations are there for offset barrier events, but even in an offset barrier event, that near side wheel is going to shunt out the crush like it did in the video that Tesla showed on the delivery event. So I don't know. This is a real mystery. I did put up some illustrations of kind of more evidence of this mystery. Tesla's crush base for their product tends to be defined, or you can take a pretty good estimate of it based on the fore-aft length of their frunk. And what we see on the CyberTruck is the fore-aft length of that frunk is not nearly as big as some of the other products. I'll leave it there. This is a mystery. It's going to be interesting to see how this truck performs as more tests are done and more data comes out. Let's see if that was it. Yeah, that's it on that slide. The next slide is 225, the same one. So Lars described a center-fed casting. I believe and recall, as I've seen this casting before, that this is going to be up onto this top corner of the, it's going to be into the side of the front compartment rail. Now, the height of the shock tower wheelhouse is interesting in that this is where the shock, the spring, are going to be applying loads to the body structure. You need good material property there and or thickness to survive durability loads. Now, the further you get away from your feed spot on a large casting, the more difficult it is to get good material properties and enable thicker material in local areas of the casting. Now, did they solve this problem because they have some tricks in casting to not be susceptible to material property reduction, or is it just because the wheelhouse doesn't have a lot of shape change as it goes up to this location? But that was interesting, something I keep my eye on as we learn more about this car. And I'm going to hold off on that dimensional quality because I think I have a slide about that. It might be next. No, it isn't. But if I don't get it, I'll catch it at the end. So next one is 259. So in 259, towards the right side of the picture, we see a set of 3 holes in a flat surface. That flat surface looks very much to be like the bonding surface for their front casting to door ring assembly marriage operation. The 3 holes there look to be the same holes that we saw earlier for the fasteners that were driven inside a car to out. And they were, if you recall, they were over in here. It would appear that the bosses that we see there, the 1, 2, 3 bosses forward of that surface, would be the forward set of framing fasteners casting to door ring, and they would be hidden behind this fender. So those would be outside of car driven inward fasteners into those castings. So bolting down the front body hinge pillar in 2 different planes, front to back. That's good with that one. Next one's 350. Yeah, and this is where Lars was asked about the dimensional quality of the casting. And he didn't get a chance to answer the question. But anybody anybody working on these large castings for automotive know that that's an important consideration. Even if you have great dimensional quality of your casting, if you are used to setting your side structure systems to your front compartment as a fixture position, and having slip planes to allow for a good cross-car dimension, this is going to be a challenge, because in this system we see the door ring coming laterally to the front casting, and that casting horizontal surface very much appears to be what sets up the cross-car fit and cross-car dimensional status of the vehicle, of the body itself. So as we saw earlier, door fits, they're probably pretty good. Again, depending on what the front fender and the rear quarter, how they're building to the car. This, with respect to casting dimensional, would leave you to keep your eye on, let's say, A-pillar to windshield cross-car fits. And that's the challenge here. Okay, next one is 718. And 718, we see here, or I think we see here, provisions for the rear quarter attachment to the body structure. They look like outside a car driven to the outside a car, through the quarter outer and into the casting. And then you would imagine that wheel lip molding that the CyberTruck has would cover these up. But that appears to be this area of the rear quarters attachment to the body structure. Oh, and I wrote down here, yeah, this is an interesting product, right? You've got large exterior panels that have lots of flat surfaces that are attached at different locations on the body structure. So I could imagine how this would be a dimensional quality challenge for Tesla, because it doesn't take too much warpage of any one of those points for a flat panel to start looking strange in reflected light. So yeah, hey, but this is their style, and it's working for them, right? 759. Here's another rear quarter attachment provision as it would appear. And this is hard to see. You almost have to stop it right at 759 and watch the progression up to 759. But on the right-hand side, almost going off the screen at the top of the C-pillar, it appears to be a folded bracket that would accept fasteners, let's say 4 aft-driven fasteners, to hold on the top front portion of the rear quarter panel. Next one, 757. Did I go back? Sorry about that. Yeah. So this, what's this one about? Sorry. Yeah. So rear shock, rear spring attachment. We see in this frame that there's a hole in the casting. Looks very much in the right position for where a spring would be. We see some bosses in the casting rear of that. But then there's a boss way far forward. We don't see the underside of this casting. But just interested to see how this rear spring attaches, because I don't see too much from the top side. It's not generally where you would do it, but an interesting spot of the casting. 822. So in 822, we see the rear casting and we see the rear rail and the 6-bar. This is all about the 6-bar to me. The 6-bar comes into the rear rail at a great spot fore aft, but its trajectory as it goes towards the middle of the car and waves forward is not ideal for structures, for sure. I think this is probably another good example of how Tesla compromises lots of things to get a low-cost execution that works at least acceptably for many different attributes. You know, was this rear motor position that drove this? Was it casting flow? Don't know, but certainly something was compromised here with the 6-bar topology. And hey, maybe with their structural performance and body interface stiffness expectations, that this is fine. The other thing on here, and I wrote down in my notes, geez, would you look at the web thickness just forward of the rail wave geometry? So on the near side, right side of car, kind of the bottom right portion of the image, as we walk forward from the rear rail, you know, with the waves, and then it gets to this top side stiffening formation, and there's a Y. There's a boss there too, but there's two ribs come together, and there's a filled in Y, and that's a really thick spot of the casting. Now, maybe I haven't seen this from the underside. Maybe they can core that out from the bottom, but in my education, die engineers would tell me that would be something to avoid for porosity, and hey, maybe they got a way around that. Maybe they got some tricks. Maybe they don't care about porosity here, but that's a lot of material right there. Notice that the rear casting does not interface the occupant compartment at all like the Tesla Model Y did. This casting does not make up the underfloor under the rear seat at all. So what I wrote that down was in the Model Y GigaCast, you could very easily see where they had casting cracks because they put these little beta patches or forget what butyl patches over them. In this car, maybe there's some little cracks in there, but we won't know because they're not patching them. So just a funny one if you've spent time with the Model Y teardown. So 754 is the next one. So when I saw the orientation of these wheelhouse ribs at the casting level, it was a real head scratcher. That's not normally the orientation that you would put stiffening features on a wheelhouse. But when I saw this picture here, it started to make sense. I think what Lars has called the sail panel casting, the thing that's just above the wheelhouse and attaches to it somehow. Lars had commented that part or that area of the structure is significant for torsional stiffness of the body structure. I think he said 25%. So if you consider that this is a big load path from the top of the C-pillar through the sail casting, and it wants to get to the rear spring seat. It's got to go through the wheelhouse. So now I can start to see how these stiffening features on the wheelhouse are really to bridge the load path between the sail panel casting and the spring seat. And it looks like one of them might even help the interface of that sail panel casting. All right, and the next one, is that it? So yeah, hey, that's it. I hope everybody enjoyed it. More will come out of my mind on this one, I'm sure. So maybe I'll put some more up, maybe I won't. But if you're interested in my background, again, go to Daphnis. But other than that, take care. Happy YouTubing.